Throughout the nearly 2 years since my last video, I have certainly not been idle on the organ project. From new ranks to Arduino coding projects, the next few minutes are a mostly chronological crash course on what has changed. First, however, I'd like to address a question I received regarding a previous video. I was asked why I wired the organ's power system to be controllable from my phone. This is because I spend so much time working in the chamber and testing various systems. Often I want to turn on a single blower or only turn on the power supply with no wind. When I'm buried deep in the organ, it is extremely convenient to be able to pull out my phone and make it so. Although I might not use it permanently, I coded an Arduino combination action that interfaces with the rest of the control system. This proved to be an excellent academic exercise on CAN bus communication. The Arduino reads piston inputs, stores the combination memory, and sends the proper commands to the draw knobs. I wired the piston contacts a number of years ago when I rewired the keyboards, but I had not yet wired the toe studs. I wired the toe studs to a convenient connector to ensure that the pedal board remains easily detachable. In addition to simple general pistons, I also coded routines for special pistons such as reversibles. Here you can see this in action with the choir-to-pedal coupler. Because the rocker tablets are still original and do not have contacts or electromagnetic actions currently, all the couplers are on knobs. I coded the Arduino to act as both a setter piston combination action and a tripper combination action. Holding the set button and then a numbered piston stores the current registration to memory, but so does holding a numbered piston while changing the registration. Ultimately, I will probably replace this temporary Arduino combination action. Instead, I intend to use the knowledge I gained for other organ-related projects. More on that in a moment. I have also been wiring the choir division, and currently 3 of its ranks are playable. A unit 8-foot and 4-foot principal, a unit flute, and an independent 2-foot principal. I moved the 2-foot principal chest, and managed to fit it between the 3-rank choir chest and one of the great walkboards. Here's a sound clip of the 2-foot. The 3rd rank on the 3-rank choir chest is a Hook & Hastings Echo viol in these photographs, but I have since replaced it, and its part of the chest has not been wired yet. Including the choir 8-foot principal, I now have 4 independent 8-foot diapasons, each with their own basses, with the notable exception of the lowest 6 notes of the choir diapason, which are borrowed from the great second open. Here's a sound comparison. A few miscellaneous projects include restoring the Wurlitzer chrysoglot, releathering a swell primary to fix a dead note, and installing the swell tremulant. Most of the work needed on the chrysoglot is due to rusty metal, so I've been restoring the bars and replacing all of the hardware. The swell tremulant has been extremely fun to use for theater-style music. Here's an example recorded soon after the choir division was wired and the swell tremulant installed. With an Arduino, PWM driver boards, and 88 transistor breakout boards, I have been working on converting one of my pianos into a player piano. Using my experience with the combination action, I intend to integrate the piano directly into the existing control system. I hope to have volume control using pulse width modulation, and connect the piano to the organ wirelessly via Bluetooth. I guess I'll find out if the latency is low enough. I realized that pulse width modulation causes audible frequencies to be produced from the solenoid coils, but so far in testing this is minimal and can only be heard very close to the solenoids. I'm wiring all 88 keys so that the piano can be used separately from the organ to play full compass MIDI files. So far, I purchased the needed solenoids, made a working prototype of the Arduino setup using LEDs, and drilled the necessary holes beneath the backs of the piano keys. Over the summer of 2024, I acquired an 8-foot clarinet and a Kimball 8-foot viol de gamba, I believe to be from 1913. The gamba replaced the echo viol in the choir division, although it is not yet playable. The clarinet replaces the fugato on the swell chest, and I'm quite pleased with the sound. However, I have been cleaning it and carefully adjusting tongue curvatures to quicken a number of slow notes. Most recently, I wired the top octave swell chest, began replacing the tuning slides on some treble pipes, and finally installed the last of the draw knob actions. The top octave chest allows the swell stops to extend an octave beyond 8-foot high C for supercoupling. And with that, we reach the current state of the instrument. To conclude, because I can, I attach the MIDI out from the console to ground org. Here's the result with both instruments at full organ.